also want to confirm if you can hear me clearly.
We can hear you.
Okay, thank you so much. Thank you for confirming that. I apologize for coming late. My car gets stuck in the snow. I think I just get a way out. So our meeting today is actually going to center on final exam. And of course, I'm actually going to walk us through the areas, uh, the final exam actually going to cover. And I need every one of you to pay attention as I'm not going to go outside the area in the practice. Okay, so I want to share this with you really quick, and I need someone to confirm if you can see what I just shared right now. So everybody's seeing what I just shared right now. Can somebody confirm if you can see what I just shared right now?
Yeah, we can
Yeah, we
see
can
the
see it.
practice exam.
Okay,
Yeah, we
thank you
can
so
see
much.
it.
Thank you so much. Before I'm gonna start this morning, the moment I first want to commend every student, participated in the recently concluded group presentation. After, if you submit, you know, just returning your project, of course, all the group has A, except that some has more A than other, but at least can assure that every group actually as A because you perform excellently. So we started on a very strong note. I also want us to finish the semester on a strong note. I want to confirm to you in the exam, one of the problem in the exam we centered on factor analysis. I need you to pay attention, everyone. I'm also recording. I'm also going to publish this recording. Uh, I want to confirm to you, one of the question in the exam, we set out on factor analysis, and you are not going to make it somehow. Okay, I'm going to give you an arrow output. That will be similar to exam two. So, um, if you have not seen exam two solution, so definitely I will revisit that. I've asked my TA to post that, and I will ensure that you all have it. So if you take a look at this problem, if you take a look at problem one now, this practice problem is also in the exam two. Now I provided a solution here. Take a look at that. Can you see that? Like here, they say examine both the covariance and the correlation matrix. Which one are you going to recommend? This is my solution. Okay, so this is like solution, part of the question I was asking exam two. Okay, so I just wanted to take note of that. So you need to read that. Now, in this factor analysis, sorry, in the principal component. Let me say this again. I think that was a slip of tongue. That would be principal component analysis in the final. I'm going to say that again. There will be principal component analysis in the final. If you take a look at the first question here, this is on the exam two, okay? Where I'm actually going to attach the arrow output. You don't need to do anything in R, okay? So look at my answers here. How many components will you retain based on the matrix? You can see what I put here as a solution. Solution is the one is in blue. Okay, so take a look at that. Interpret the force eigenvector. That is the interpretation. Okay, make sure you get yourself familiar with that. What is the variance of the second principal component? Okay, you can see that. Okay, that's my solution. Okay, so all of these fall under principal component analysis. Why are the principal components uncorrelated? Okay, it's because each principal component is constructed to be orthogonal. Okay, so in general, what are the principal component scores? This was not part of the exam too. I think I added this. So please pay attention and go over all of these. I think I gave the definition of a principal component score. Okay. Now, uh, there's going to be an handout, that will contain our input that that's going to be part of the exam. Like I said, you are not going to use our software in the exam. I'm actually going to provide you with an arrow output. So let me just say this specifically. One major question in the final we centered on principal component analysis. And the arrow output is going to be given the way you have it right now. And of course, several questions will be on that. Is there any question? That is one major problem. That's going to form one major problem in the final. Now, in the absence of that, I would have confirmed just like the same way that you have it in the exam too, there is going to be Bayesian network. You're actually going to have a scenario where, if you take a look at this guy now, they're going to describe in this way, that will look like that. Homework depend only on party and smart. Mark depend only on smart and creative. Or project depend only on smart and creative. Or success depend only on homework and project. And happy depends only on party, mark, and success. Okay, so what the examiner wants here, just like similar to exam two, they actually want you to draw a Bayesian network. Majority of the students actually perform excellently well in this question in exam two. So I'm also expecting you to reciprocate the gesture this time around in the final. So if you take a look at this guy now, so the solution that I provided, can you see that? Look at that. That's not beautiful. Look at that. So that is going to be tested again. So Bayesian network. The Bayesian network is also going to be tested in the final. So where you're going to be given scenario and they're going to ask you to draw the network, just like the one that I'm actually showing you right now. Now, under that, they're going to ask you write the joint or distribution as a product of conditional probability. Of course, in that case, you're going to make use of the structure. You can see that creative, smart, and party, they do not have parents. They actually starting alone. And that's why you see here, you're going to see the probability of creative, probability of smart, the probability of party. Okay, so stuff like that again is also going to be in the final. Okay, and of course, they're going to ask you what is the number of independent parameters needed for each conditional, probability or table. Okay, so I just wanted to take note of that. Can you see the way I put it here? Okay, there are some of you that didn't get it right, but the majority get it right in the exam too. But for those who are say struggling with that, so of course this is how we do it. Okay, I'm going to tell you this. Each of the node, each of the variable here is actually binary. Each of them has two nature. It's either you are creative or not. It's either you are smart or not. It's either you attend a party or not. It's either you complete your project or not. It's either you have a mark or not. It's either you have homework or not. It's either you are successful or not. It's either you are happy or not. So each of these variable is categorical. It has two levels. And the moment it has two level, this guy here is going to have one parameter. This is going to have one parameter. This is going to have one parameter. Okay. Now that's why you see here in the table, you can see the probability of creative having one, probability of smart having one, the probability of party having one. Now, situation where a particular categorical variable is actually conditioned on, let's say, for instance, if it's conditioned on one, of course, that would be two. But now that it's conditioned on two, look at that. Project is conditioned on creative and smart. That would be 2 times 2, and that would be 4. You can see where mark is where variable is conditioned on two variables, it's actually going to be 4. But where it is conditioned on three variables, okay, three variables would mean 2 times 2 times 2. So what is 2 times 2 times 2? That would be 8. Okay. So I just I realized that some I think a few students, not I think about 5% of students, didn't get the table right. Okay, so it's actually simple. Where the variables do not depend on another variable, and it has two categories, then we actually gonna write one as the number of parameter. That's what you got, because the moment I know the probability of creative, then I will be able to know the probability of not creating. So one is enough. So for creative, you're actually gonna have one where it is not conditioned, you're actually going to have one. Where it is conditioned on one variable, you're actually going to have two. Okay, where it is conditioned on two variables, you're actually going to have four. Where it is conditioned on three variables, you're actually going to have eight. Is there any question here? Is there any question? Is there anyone that is actually get stuck on how to figure out the number of parameter in the conditional probability table? Or can you all confirm again if everyone is still hearing me clearly? Is everyone still hearing me? Okay. Now, another question now asks, what is the total number of independent parameter? What is the total number of independent parameter is actually asking you to add all of these together. Okay, so let's take a look at that. Can somebody get me the total here? Can somebody try and add this up? What do we have?
So
What is that?
27.
27. Thank you so much. Now you can see a different question asked. Okay, a different question. This is different. They ask you to set up a table, and another question now has, what is the total number of independent parameter? So if the parameter you get in the table is wrong, then that answer is actually going to be wrong. Okay, so that's going to be 27. So we arrive at 27, adding all this together. Now, you know what I just did right now? I needed to pay attention. I just finished two major questions in the final. I'm going to repeat myself. Problem one centered on principal component analysis. One of the major problem in the final, we centered on principal component analysis. Like I said, I'm actually not going to ask you to use R. Okay, R is going to waste your time. So I'm actually going to provide you with an arrow. How put for problem one? I mean the one for principal component analysis. Now for problem two, it's actually going to look like it's going to be a question on Bayesian network where I'm actually going to specifically, I'm going to give you a scenario and I'm going to ask you to draw a Bayesian network. And after drawing a Bayesian network, well, several questions, getting the conditional probability, like getting the number of independent parameter, like getting the total of number of independent parameter will be asked. We just finish two major problem in the final. Now, if there's no question, I'm actually going to go to the third one. Now, I can confirm to you that, you know, the problem three, one of the problem in the final, we actually centered on graphical lasso. But let me tell you this. It's going to be a theoretical question on graphical lasso, and I need you to pay attention. And I'm going to talk about this problem three now, and you're going to see the way the question is going to be asked on that. Now, let's take a look at problem three. A problem that look like this area is actually going to come in the final. Now, take a look at this. A National Environment Agency is tracking the occurrence of natural disasters across various states. They process a data set capturing the monthly disaster occurrence indicator for 50 states over the past 15 years. So when I say 50 states, probably I'm talking about United States. Okay, now each state is represented as a column in the data set, and each row corresponds to a month. So, in each column, you have a state, and in each row, you have months, resulting in a data set S having 180 rows and 50 columns. Of course, there's going to be 50 columns because we have 50 states. 180 rows, maybe because they consider 180 months. Okay. Now Sij is 1 if region J experience a disaster in a month I. Okay. Now, when Sij, don't forget that will be a matrix because you have data set in row, you have data set in column. What you have in column is actually the state. What you have in row is actually the month. So the Sij in that situation, if Sij equal to 1, then you are actually trying to say that a particular, if it is 1, if Sij equal to 1, they are trying to say region J experience a disaster in month I. Okay, don't forget, in the United States, it is not all states that experience disaster in a particular month. So what we're trying to say now, situation where Sij equal to 1, that we're trying to say that particular corresponding state in that column, experience disaster in that particular month. And the situation where Sij equal to 0, then it means that particular state did not experience disaster in that particular month. Now, let's take a look at the question. So, which means they are trying to tell you here that uh, we are working with a categorical situation. Okay, each state actually going to serve as a node, and this node is categorical. Categorical in the sense that it's either a state experience a disaster in a particular month, or they do not experience disaster in that particular month, which is categorical. Now the question now say, the agencies seek to analyze the correlation of disaster occurrences between different states. They consider constructing a graphical model using the data. Between the Gaussian graphical model and the Ising model, which one would you recommend for them to use? Explain your reasoning. Please, I need every one of you to pay attention to this question. Let me tell you this. You know, uh, when I was listening to your project presentation, I was highly pleased because, some of you did a great job. Even, some of you go beyond our scope in the class. That really touched me a lot. Now, let me tell you this. Generally speaking, okay, in a graphical model, it's either a random variable is continuous, or is categorical, or there's a mixed situation where it is categorical. Okay, we call that model Ising model. Please pay attention. Okay, take a look at this. Can you see that word Ising? That Ising is what we've been dealing with in class, because all the node in the class, they've been categorical. I'm going to say that again. They've been categorical. But situation where the node is not categorical, because we could have situation where the node is continuous. If the node is continuous, then we're going to use Gaussian graphical model. Okay? Gaussian graphical model. We use the word Gaussian apply to continuous random variable. Okay, so the bottom line here is we use Gaussian graphical model for continuous random variable. We use Ising model for categorical variable. Now, in the scenario described above, because we're told it's either a state actually experience disaster or not, which make each state to be categorical, then I'm actually going to say, if I want to analyze the correlation of disaster, occurrences between different states, then I'm actually going to use uh, icing. But this is what I'm going to say. If you want to find correlation, correlation doesn't work with categorical variable. I'm going to say that again. Because of the fact that they mention correlation, the fact that they mention correlation, then I'm actually going to use Gaussian graphical model. Okay, the Gaussian graphical model, or somebody said, I believe we use a Gaussian graphical model on a discrete matter data. Would I think have been better in practice of this? Okay, now I need us to pay attention. I need us to pay attention. If I want to analyze categorical variable, okay, in a network, we use Ising model. If I want to investigate continuous, we use the Gaussian, okay? Now, this is what happened. In this situation, where a state can experience, uh, you know, even though I know analysis of correlation should be based on Gaussian graphical model. I'm going to say that again. Analysis of correlation should be based on Gaussian graphical model. But you have to put the nature of the node into consideration because the node is categorical. It's either a state, experience, or a disaster or not. And that is the reason why I said this. Look at that. I said the Ising model is recommended because it is designed for binary data, like this data. Okay, so this is the bottom line. If you want to talk about continuous, if the variables are continuous, we use Gaussian graphical model. If the variables are categorical, we use Ising model. So based on what is described here, the variables is not continuous. The variables is categorical. Categorical means binary. It means binary. We have two options. We have two levels. It's either a state experience disaster or not. Is there any question on this? So the right answer is Ising model. Ising model is used when we are working with a binary variable. But Gaussian Gaussian graphical model is, applied to continuous. Now I need you to pay attention now. Look at number six. Number B said, after fitting the model, they derive a graph structure showing relationship between regions. States not connected in the graph have been omitted. Okay, their interpretation suggests that the occurrence of disaster in California appears to be independent of those in Texas. Is this interpretation valid? Please, I need you to pay attention. You remember in class, situations where when you apply a lasso penalty, okay, we're talking about the graphical lasso, okay, the idea of a graphical lasso is actually to shrink, uh, is to induce sparsity. Induced sparsity, is to force a weaker relationship to zero. Okay. Now, if we force a weaker relationship to zero, that will result into an absence of edge between two nodes. Okay. And the conclusion is going to be they are conditionally independent, given that we have observed the rest. Now, according to the interpretation, it said, uh, you know, uh, they said their interpretation suggests that the occurrence of disasters in California appears to be independent of those in Texas. Now, so what happened? Because of this, take a look at that. I said the independence interpretation is valid because the graphical model only capture conditional dependencies. The graphical model does not capture conditional independencies because the conditional independencies have been eliminated when you force in lasso penalty. Does that make sense? And that was why I said specifically here, I said the interpretation that disasters in California and Texas are independent is valid based on the absence of an edge between them in the graph. Okay, this indicates conditional independence given the other states in the model. So California and Texas are not connected in the graph. Situations after, maybe after applying graphical lasso and two variables are no longer connected, then you can actually say they are now conditionally independent, given that we have observed the rest. Is there any question here?
Yeah, so with the model we have, and this might be something we already learned about, but is proximity on the model does that mean a higher correlation than distant on the model? So like Maryland and Illinois are highly correlated, but Maryland and Ohio, which is in the bottom right, are less correlated.
That's a very good question. There's a difference between when you're talking about the distance, between, what I know is a distance can exist and there's still kind of some form of correlation. Okay. Then it is right that when you say proximity, okay, proximity indicates a stronger relationship. Okay, proximity indicates a stronger relationship. But what we are trying to talk about here is a situation where two nodes are not connected. Okay, another example here, if you take a look at the New York and Virginia, New York and Virginia, there's no any arrow connecting them. I can still say Virginia and New York are conditionally independent. Okay, now that is a word that's what we want. But if you take a look at the New York and Ohio, look at the New York and Ohio, the moment you have an edge that connect, you have an arrow that connect. The arrow connecting two variables means they are conditionally dependent. Conditionally dependent actually means that they have arrow connecting them. So when you talk about proximity or distance, okay, that is now talking about a different thing. The proximity is talking about a stronger correlation, while distance talk about a weaker correlation. I don't know if I've answered your question.
Yeah, you answered it. Thank you.
You're welcome. Now we have succeeded in the three modules in exam. I mean, the three questions, the three major problems have now been addressed. We have one more to go. And the third one, the fourth one is going to be simple. Now let's talk about fourth one. The fourth one is going to be based on a topic model. Please pay attention. I want everyone in this exam to score 100%. Imagine I'm going to set four problem with 2 hours. You're going to have enough time to do well. Now, the problem for the one of the problem in the exam we centered on topic model. Take a look at that. We want to convert the document to document term matrix for simplicity. Let's assume our vocabulary is machine learning, learn, machine command learning, statistical class, and these are the words. They're going to give you different words of interest. Assuming the first four documents in the corpus are given below, where the D1, if you take a look at that, in document one, machine learning is super cool to learn and apply. In D2, I am currently learning statistical machine learning. You can too. In D3, start 451 at UMN is the best machine learning class you can ever take. That's correct. Yeah, I'm confirming that. Okay. Now, learning statistical idea is crucial for understanding machine learning, of course. Now, when you take a look at this, we want to look out for this word. Please pay attention. Okay, we got some words here. We want to look out for them in this document. You were given four documents. Please pay attention. You want to find out those words. What I need you to do is to draw a matrix. Oh my God, you're going to draw that. Okay. Now, when you draw that, you create document D1 up to D4 and the word. Look at the word given. You were given machine learning, statistical, class, and can. Then I write it here. Can you see that? How many machine? How many times they pronounce machine in document one? Please pay attention. Document one. Oh, one time. Can you see machine? Just one time. I'm going to write one. Can you see one? How many times here they pronounce learning? One. Do they have a statistical in document one? No, zero. Do they have a class in document one? Zero. Do they have a can? Zero. Can you see that? So they're going to give you some words and they're going to give you some document. Then you are going to be the one that will set up this document time matrix. Because if you want to, if you as a statistician or a machine learning expert, if you actually want to analyze this, you need a numerical information. So what we're doing right now is actually to convert from textual information into numerical representation. Now I've succeeded in formulating my matrix. Look at my matrix now. Is there anyone who doesn't understand this? Is there anyone who doesn't understand how to formulate that? Okay. I'm
Just
actually okay, go ahead.
just to confirm, like if a word appeared twice in a given document, we'd mark it as two, right?
Exactly.
Okay.
So we are actually having a count. That's a good question. We're having a count. So this is like telling us the number of time a word appear in a particular document. Where there is no that word, you cannot leave the cell empty. You have to record zero because you need a complete table. Now another question now asks. I think I'm going to stay 10 more, I'm going to have an extended time of 10 minutes. But if you have any other lecture, you can log out when it is 11, but I'm still going to be here. This is being recorded, okay? Because I still have a lot of things to say after reviewing this, and this is being recorded. Now, do you know I'm already done with this, putting the table in place. Now the next question now has, now suppose we have a document time matrix of 500 document in 200 words. Okay. Now, name two dimensionality reduction technique that can be used to handle the data. Now there are several dimensionality, reduction method that we have used in topic modeling. Remember, I talked about latent semantic analysis, the LSA. I talked about the latent or Dirichlet allocation, the LDA, and I also talk about PLSA. I talk about non-negative factorization. I think there are several of them. So here I just say name two. Look at that. I'm done. I'm done. Name it too. Can you see that? Oh, I forgot this. There's going to be five problems. Initially I was saying four because you have 2 hours. You have 2 hours for the exam. So you're going to have five problems. Now, the last problem that I want to talk about, you remember we talk about portfolio analysis. Okay. Now, uh, what if you're giving something like that? Assuming that we have a simple portfolio of two mutual funds, one invested in bond and the other invested in stocks. Okay, this particular person actually invested in two different assets. Okay, let's further assume that we expect a stock return of 8% and a bond return of 6%, and our allocation is equal in both funds. Allocation, please pay attention. Allocation equal in both funds. Look at what they wanted to find. Obtain the mean of the portfolio. Of course, because I have two assets, it's going to be W1, R1 plus W2, R2. Now, because they say they have equal in both funds, they may not be equal in another question, but here is saying equal, then that would be 0.5, 0.5. Do you see that? If they only mention in another question 60% for a particular asset, automatically it will be 40% for the other asset. And in this question, they've given you the return, 8% and 6%. You can see I put them here. Then I multiply, done. I'm done. Is there anyone who doesn't understand how I got this? This is simple mathematics. Okay, in exam, you need scientific calculator. Okay, this is going to be easy calculation. Okay, now, then another question say, calculate a measure of the riskiness of the portfolio. Okay, if there are two, this is the formula. This is the variance formula. W1 squared sigma 1 squared plus W2 squared sigma 2 squared 2W1 W2, the covariance. Take a look at that. Now, uh, you know, uh, you they're gonna give you the value for the variance of each. They're gonna give you all of that. So here, assuming that you are given the sigma 1 to be that, sigma 2 to be that, your correlation is actually that, you can compute the covariance. Okay, they're going to give you all of this. They're going to give you the sigma, sigma 2, sigma 1, the correlation. Then you can get the correlation using this formula, because the correlation, you can get a covariance using this formula. The covariance is just correlation multiplied by sigma 1, sigma 2. So now the moment you plug in all of that here, you're actually going to get the variance. Okay, if this is variance, the square root of the variance is the standard deviation. Okay, so now let me say this. I'm not going to, in the exam, there's not going to be factor analysis. I've changed my mind. No factor analysis. I'm going to say that again. No factor analysis. Now, let me repeat myself. In the exam, there's going to be question on portfolio theory. Okay? Portfolio theory that may look like stuff like this. In the exam, there's going to be question on topic model. In the exam, there's going to be question on graphical lasso. Okay? I will advise you read your graphical lasso. There could be some theoretical question. There will be a question from Bayesian network where you're actually going to draw. Make sure you start practicing. There will be a question on principal component analysis. Okay. Now, I think I just mentioned that. I'm going to repeat that again. Number one, there's going to be 5 major problems in the exam. The first one of the problem we focus on principal component analysis. You're not gonna make it survive. You don't need software for this final exam. I'm actually going to give you arrow outputs, and of course, several questions will be asked. Now, the one major question is the principal component analysis. Another major question is Bayesian network that will be similar to exam 2. Okay, then another problem will be on graphical lasso, where they're going to test your knowledge on Ising model and Gaussian Gaussian graphical model. Okay, and just follow the way I actually explained that to you. Understand when there is a connection between two variables and when there is no connection. When there are connection, it means they are conditionally dependent. When there is no connection, which means if there's an absence of an edge connecting to variable, that means conditionally independent after, putting the rest into consideration. Now, I also said there's going to be a question on portfolio theory. Okay, there's going to be question on portfolio theory. There's going to be question on topic model. The question on topic model will be very easy one. Okay, at this junction, I actually want to appreciate every one of you. It's a privilege for me to be your professor this semester. And let me tell you this, even though I know there is difficulty, but what I believe what I believe in life is ability to be able to handle any difficulty. Okay, ability to be able to handle that. I'm actually seeing success. You know, Success is not about what somebody have achieved in life. It's not about the resources that you have. It's not about your knowledge, but it's about, to me, success is ability, to rise after many falls. Even though I don't wish you to fall. Okay. But when you fall, pick yourself up. Okay. And I'm actually seeing failure as inability to rise after a fall. When somebody fall, I've fallen before, I pick myself up. When somebody fall and you don't want to pick yourself up, okay, that is what I'm going to call failure. But provided you fall and you pick yourself up and you are able to manage challenges, on the road to success, because let me tell you this, we are all targeting a destination, a smooth. We want our destination. We know the kind of destination we want, but what I've seen in a stochastic world, what I've seen in a probabilistic space, the route to our destination may not be smooth. I don't scare you, but I just want you to know the route to destination may not be smooth, and that is why you need yourself, and you need yourself to be able to figure things out. Like, okay, you need to come up with a belief that even though it may be difficult, but you come up with a belief. You start with a belief that I will figure it out, no matter what, no matter the situation, no matter what, you're actually going to figure it out. And what is the way to figure it out? Number one is don't be scared. Don't be scared at all. Don't be scared at all. Okay. So one of the way to figure things out is get the strategy. Okay, like you know what is coming in the final. All what I just need you to do is spend your time on those areas that I've mentioned. You deserve to score 100% in this final. When you have not scored A before, you can score A now. And another thing I'm going to say, don't listen to people, because at times some people will pull you down. Some people say, oh, nobody can score A in that course. But you're going to tell us, you're going to say, "Oh, thank you, but I'm going to score A in this course." So don't listen to what people say about you. You know yourself better than anybody. I'm going to say that again. There's this thing I used to tell my students and people around me and my children, that whatever people say about you doesn't define you. I'm going to say that again. Whatever people say about you doesn't define you. If the whole world is against you, do you know how they're going to succeed? They're actually going to succeed if you join them. You should be the last man standing in your case. I'm going to say that again. You should be the last man standing in your case, even if the whole world is against you. But if you don't join them, okay, then you're actually going to succeed. You're actually going to be victorious at the end of the day, and you're going to shock them, and they're going to say, oh, against all odds, you still make it. So according to a philosopher, he said the road to success is very narrow, and everyone want to pass through the narrow way. Going by the accommodating capacity of the road cannot contain everybody at a time. Some will go, while some will wait. Who are those that will go? Who are those that will wait? That question is left to every individual to answer. But do you know what my friend said? He said, the whole world will step aside for a man or woman who know where he's going. If you know where you are going, if you are fully determined, the whole world will step aside for you, and they're going to say, go. So, and let me tell you this, when you are looking for something and you don't get it on time, don't quit. Okay. You need to have the spirit of perseverance. You need to have the spirit of, strong determination, spirit of endurance. My friend in economics once said, those who will get the resources are those who can stand for a very long time on a queue. Okay, it doesn't really matter the number of time you stay on the queue, but make sure at the end of the day you get the resources. And that's why you need to, display the highest manifestation of endurance, perseverance. Once again, you've started strongly. I want every one of you to start to actually finish strongly. Okay. Uh, you know, I want a situation in the exam where everybody's going to get, hey, you know what is coming? Just practice. I don't want you to lose any point at all. I don't want you to lose any point at all. So just be committed, just practice. And the moment you practice, even though things may be difficult initially, but with a consistent, practice, one of a philosopher said, practice makes perfection. The more you practice, the more you get your confidence. the more you get to understand things. Okay, so I wish you best of luck, and I wish you, in the final exam, and I wish you best of luck in your career. I'm actually going to have my office hour on Thursday, which is going to be the last day of office hour tomorrow. If you, in case you need more clarification, please let me know. Is there anyone who actually you maybe have a question, or you need a clarification, or you just have something to say? I'm actually going to listen to you. Is there anyone before I go? Okay, so at the junction, make sure you keep track of the announcement section, because information is going to be going out. And don't also forget to fill in the student rating of professors. And you can also go on Google. There's a website called Rate My Professor. Be honest, if I do good, put that. If I do bad, put that. Okay. And don't forget to fill the one on the on the canvas too, the student rating of professor. And for those of you with the extra credit, after the final exam, I'm going to, make an announcement about that. You're going to advise me on how you want to spend your extra credit. You can spend your extra credit on assignment. You can spend it on the exam, whether midterm or final. Or let me also say this. I think I forgot. Uh, you know, assignment policy. I promise in the syllabus that I'm actually going to drop one assignment, the one with the lowest. I'm still going to do it. Okay. Whether we do 7 assignment or we do 6 assignment, regardless of the number of assignment that we expected to be completed this semester, I'm automatically going to drop one with the lowest score. Okay. So I'm going to drop one with the lowest score. Well, let me see. What is the other thing I've not talked about? I quickly want to remember before I go. I think I've talked about extra credit. I've talked about assignment. And make sure you keep track of the announcement section. Information is going to be going back and front. So make sure you keep track of that. Okay, that's all what I got. And the place of the final is still our lecture theater. If anything is going to change, I will let you know. But the time of the exam remain the same, because the university set that at the beginning. Okay, that's all what I got. See you on the day of exam. Make sure you come some minutes to the start of the exam. Don't forget, you have 5 major problems expected to be completed within 2 hours. And I can assure you, I know some of you will complete that within 1 hour, because these are the areas that I just talked about. Let me mention the area again. Number 1, principal component analysis. Okay. Number 2, Bayesian network, read wide. Number 3, graphical lasso. Okay. Number 4, topic module that we have done. Okay. What is number 5? Can somebody remind me? Let me see. I think I said graphical model. I said principal
Portfolio
component.
analysis?
You said what?
Portfolio analysis?
Exactly. Portfolio analysis. Thank you so much. Thank you so much. You do not need Markowitz. Okay. You only need, just go over what we've done. So you'll be fine. Okay. Make sure you all stay safe. The weather is crazy. Okay. Stay warm. Bye for now, everyone.
All right. Thank you for class
You're
and
welcome. You're
thanks
welcome.
for the
Thank you.
speech.
Thank you. Thank you too. Yeah. Yep. Yep. Thank you, everybody. Bye.